Hello and welcome to the last class, the second class and the last class, second and last class on a quick brush up revision on a very vast topic, ionic equilibrium. Yesterday, we were discussing and also simultaneously solving some problems on each section, each aspect, started from the BL theory, Bronsted-Lowry theory of acids and bases, proton donors are acids, proton acceptors are bases, and we extended that theory to salts, particularly the two types of salts, only providing an anion, active anion, which will show basic dissociation, and an active cation, which will show an acidic dissociation. But those are, for general purpose, are regarded as hydrolysis of salt. For the active anion category, salt of strong base and weak acid, the strong base cation Na plus, K plus, or any similar cation are defunct. They do not have any role for hydrolysis or any basic or acidic hydrolysis. So, and the other category is, say, ammonium chloride type, where you have salt of strong acid and weak base. We had completed how to find pH of weak acids, weak monoprotic acids, weak diprotic and triprotic acids. How for weak polyprotic acids, Ka1 is used for finding pH, S plus ion concentration or pH. Then other Ka values are used for finding the concentrations of other ions. And we found how common ion effect in homogeneous category can produce a buffer solution if the salt carries a conjugate with respect to the weak acid or weak base, respectively. Then the weak acid and its conjugate base, they are present in such an abundant quantity. The ratio is, their proportions are so high that they absorb, they neutralize, they undo almost completely the change of pH. The change of pH is really minimal. And we had developed Henderson equation, Henderson-Hasselbalch equation. For acidic buffer, it is pH, and for basic buffer, pOH. And for the third category of salt hydrolysis, weak acid and weak base, which we found that the degree of hydrolysis is independent of concentration, Kw by Ka into Kb square root, and the pH will be equal to half into pKw plus pK minus pKb. No concentration of the salt is needed for that category. But the other two types, where salt of strong base and weak acid is basic, there we used to follow a handy equation, pH is equal to half pH. Otherwise, if you go by the first principle, then OH minus ion concentration, because that is a basic solution. OH minus ion concentration is equal to Kw by Ka into C, numerator C, square root. Then find POH, then pH. Instead of doing that, you can use this handy pH is equal to half into pKw plus pKa plus log C. And the other category which produces an acidic solution, ammonium chloride type, you will have half into pKw plus, sorry, minus pKb minus log C. And of course, you know that the salt of strong acid and strong base, sodium chloride type, they do not, none of the two ions undergo hydrolysis. So it is just like a dissociation of water, and pH is equal to 7 exactly, neutral. And also we saw how to find the pH of amphoteric salts like bicarbonate salts, like dihydrogen phosphate, like hydrogen phosphate salts, and so on. Now we are left with today to discuss. Anil sir, namaskar. Today, the heterogeneous equilibrium. Rudra, do you have anything to ask me?
No, sir. Sir, screen share.
Let me share my screen. Yeah. Um, in heterogeneous type, the solubility product principle, now supposing a type of salt, say A, X, B, Y, it is a sparingly soluble substance, and whatever little dissociation occurs is due to solubility, is due to the dissolution. Dissociates no doubt into free ions, but it is due to dissolution first. So here the term solubility will be used instead of the degree of dissociation. The solubility is the term to be used here. This is solid phase. It remain at the bottom of the solution, which is not dissolved, which is thrown out, is not dissolved any further, doesn't dissolve to form a saturated solution with X number of A, Y plus and Y number of V, X minus. So the solubility product is the product of all ionic concentration raised to the power the stoichiometric coefficients in the valence equation to form a saturated solution at a fixed temperature. So this will be A Y minus concentration, saturated concentration into X into B X minus concentration to the power Y. Now you know how to correlate between solubility is the term. Supposing we take S as the solubility. That means moles per liter. That means it's a different meaning. It's not the molarity of the solution. Out of whatever you add to water, sec, per liter of solution, only S mole dissolves. S mole of the solid dissolves per liter. You may take 20 moles, those extra will deposit, which will be remaining in equilibrium with the aqueous phase. So per liter, S moles are found to form saturated solution, in the saturated solution. So in that case, A Y minus concentration is X times S. because X is the stoichiometry. If one S goes, then XS produces of A Y plus type. And the concentration of B X minus will be YS. And KSP definition is AY plus to the power X into Bx minus to the power Y. So this is XS to the power X into YS to the power Y. So this is XX into YY into S X plus Y. This is the general expression for the correlate between solubility product and the solubility. And there is a term called IP or Q, the ionic product or the reaction quotient. The ionic product term is very, very popular. That is, the expression is similar to KSP, but the concentrations are in non-equilibrium conditions. That means you have just added two solutions. You are looking for whether precipitation will happen or not. If not, then definitely it will either form an unsaturated solution, still hungry to accommodate more ions, or it is just a saturated solution. Supposing you take the case of AgCl, this is in the aqueous phase and this is in the solid phase, and KSP value is fixed. Say KSP is 10 to the power minus 10. So in this case, solubility is equal to 10 to the minus 5 moles per liter. So supposing you have a situation where the instantaneous silver ion concentration is 10 to the minus 3 and chloride ion concentration coming from sodium chloride, for example, is 10 to the minus 8. So the product, the two may be different, but the product is a constant quantity. So you find that 10 to the power minus 3 into 10 to the minus 8 is 10 to the power minus 11, which is less than the KSP, means it will not form a precipitate. And if it is greater, it will be the extra. Over and above the KSP value, all the ions will combine to form a precipitate, an insoluble precipitate. So IP is less than KSP. This is unsaturated solution, as you know. And IP greater than KSP, it is immediately forming a supersaturated solution. Precipitation will occur, ultimately forming a saturated solution. The extra ions will be joining together to form a precipitation, but KSP amount will remain. The product amount I'm saying. So, but if fortunately the two are same, then it's just a saturated solution. No precipitation. This you know. And here also the common ion effect is very, very elegantly applicable. For example, you have PbCl2 in pure water, and you are trying to study its solubility in lead nitrate, which is a strong electrolyte. The common ion is lead ion. So the presence of lead ion will reduce the solubility because LCP says that the the solubility process will be left favored That means more precipitation will occur, more PbCl2 precipitation will occur, and the solubility will be lowered. We don't say the degree of dissociation is lowered in this case, the solubility is lowered due to common ion effect. And the trick is, supposing, let me give you a question. Supposing I ask you to find 0.1 m lead nitrate solution. Find the solubility of PbCl2 in 0.1 m lead nitrate solution. So here, let the solubility is X. Before we are doing as S, let me change it to X. Let the solubility with the common ion effect, with the equilibrium driven further to the left and getting a final equilibrium, let the solubility is equal to X. So this will be X, this will be 2X. This is the uncommon ion. But the actual lead ion concentration is X plus 0.1. That is coming from this source. Therefore, when you write Ksp, lead ion concentration into chloride ion concentration square, then this is X plus 0.1 into 2X square. So here you have to approximate that in the phase of 0.1, X is negligibly small. So you can reduce the cubic equation to a quadratic equation so that you neglecting X in the parenthesis, simply it is 4X square into 0.1 is equal to, supposing it is 10 to the minus 11. I'm just giving a fictitious value. It will be given to you, so 4x square. So let me, it will be 10 to the minus 12. X is equal to, x square is equal to 10 to the minus 12 by 4. So x is equal to 10 to the minus 6 by 2. So it is 5 into 10 to the minus 7. So this is the
So,
solubility. Huh? Yeah.
so 10 to the minus 10.
Oh, 1 by, oh yeah, 10 to the minus 10.
No,
Hmm?
sir, ऊपरটা sir 10 to ঠিক ଥିଲା 10 to the minus 11
এটা তো ভ্যালুটা দেয়া হয়েছে না?
yes sir, yes sir, yes sir,
ଦେଇଛି, এইটা হବ 10 to the minus 10.
yes sir,
1 by 10 উপরକୁ ଚାଲିଗଲେ 10 to 10, তো এটা ହେଲା 10, so এটা ହେଲା 5, so 6 ନାଇଁ? ଠିକ
yes
ଅଛି?
sir, yes sir.
So this is the solubility in the but had you not taken the help of common ion effect, you see the solubility has been lowered. See, only in pure water, simply 4x cube. X into 2x rho square is equal to 10 to the minus 11. So x is equal to rho minus 11 by 4. So by 3 means 3. It is about by 3. 3.67, 10 to the minus. But here see 10 to the minus 6, in the order of 10 to the minus 6. So it is greatly lowered because of the common ion effect. Sometimes earlier, I'm not finding such questions nowadays. You can drive the solubility to the right by, complexation reactions. What, supposing you add some KCN. So the next equation is Cn minus plus Ag plus 2 Cn minus will give you very stable dicyanido-argentate complex. AgCN whole to the big bracket minus. So then you have to see what is the formation constant of the data will be given, the complex formation constant will be given, and then you have to find out what will be the remaining. What is, in that case, the solubility is the concentration of the uncommon ion, which is not going for any common ion effect or any complexation. It is removed so that the equilibrium is driven to the right, and finally it gets another new equilibrium. So we solve such problems. We can do that. If you want to have a look onto such kind of problems, I will show you. We cannot say that it's not, such type of questions are not appearing, so we will not do that. So it's not a good thing. So let me show you such kind of problems. Now I'm showing you not a cyanido complex, similar type, is a amine complex. Calculate, I am showing you a problem to save time. Calculate the solubility of silver bromide in zero point 0.1 m ammonia. Assume that diamine silver ion is the only complex formed, and the two data are given, KSP of silver bromide. Welcome those who are watching from the YouTube directly or indirectly, now or later. Welcome. So today is going to be the second and last class on ionic equilibrium. So I'll be solving several problems from the past uh, JEE and NEET examination, IIT JEE and NEET examination. Now here in this problem, the KSP is given and the formation constant for diamine silver is given. It is a very stable complex. The formation constant is so high. So I have written down the two. The assumption that you have to make, that whatever silver ion is formed, all silver ion goes to form diamine silver complex. All. That is the assumption. That doesn't mean that it's zero. You think that it is zero, but it is not zero, non-zero. That we will find out. Why? Because the formation constant is so high, this second reaction is almost irreversible. So whatever Ag plus is formed in the first, without adding ammonia, all will go, for example, and finally, that means before adding ammonia, supposing XX, this is the solubility is X. It is the concentration of the uncommon ion, X. And all X has gone, forming, previously it was X. And X 0.40. And X has become totally zero, vanishes. And 0.4 minus 2X, this stoichiometry is 2X, and this is X. But since it is not zero, it is something very close to zero. In ionic equilibrium, you will be playing with values close to zero. 10 to the minus 50, 10 to the minus 40. These are, mockery. Though appearing as a mockery to calculations, still they are very valuable data, information for prediction purpose and analytical purpose. So let it be Y. If this is Y, this is Y. This is only one silver ion. That silver ion is in equilibrium with this AgBr and Br minus, and this Ag plus is also in equilibrium with ammonia, the unreacted ammonia, and also the complex. This equilibrium constant is called the formation constant. This is KSP. Now see what we have done. I have already explained that what you have written, what I have written there. So this is KF. KF is x divided by y into 0.4. I have neglected 2x in the face of 0.4. Many approximations you have to do. So simply y into 0.4 square, because the is there, so that you get y in terms of x. You get y as a function of x. You get it. Then use the KSP equation. AG plus is x. AG plus is y. I'm sorry, y. I have used the value of y here. Y into BR minus is x. So there are two equations. One is x square is equal to this. From this second equation, we get x and we put x here to find y. So solubility of AgR in a solution is much greater than in pure water. In pure water, in square root method, simply square root of KSP will give you 7 times 10 to the minus 7. But now it is 2.8 because X is the concentration of the uncommon ion and that is the solubility. Common, the not common ion, the ion which has been removed almost completely is not the solubility. The solubility is known from the uncommon ion, Br minus, which is not reacting in the second state. You understood? So, if it is complexation, you have to believe that the one which is undergoing complexation is completely removed. So, you write initial X and whatever given the complex, the ligand, the complexing ligand 0.40, then this is completely gone, 0. You write first 0, 0.4 minus 2x, x. But actually it is not 0, it is y, and put y here. That will solve two equations, and from the two equations you can get x and y. Got it?
Yes, sir.
And this type I am not, I was scanning from even 2012, 10, 12. I'm not getting any, maybe in advanced you might get. So you must be equipped with all types. Even we had discussed, this is now here see how common ion affect both homogeneous and heterogeneous. They are playing interesting roles here. 0.2 m zinc chloride is treated with a saturated S2S. Saturated S2S is always 0.1 m, which is also 0.5 m in HCl. Some HCl has been added so that the molarity of the H plus ion is 0.5. Predict whether precipitation will occur or not. Under this condition, it is not only S2S. You have suppressed the dissociation of S2S. The the homogeneous equilibrium has been first taken care of. The sulfide ion concentration has been reduced to the extent that it may not, the ionic product may not be exceeding the solubility product of zinc sulfide, and precipitation might not occur. Might not occur. मुझे लगता है क्योंकि in group 2 analytical chemistry, where we only precipitate out the group 2A, the bismuth, copper, mercuric, lead, cadmium, and group 2B, arsenic, antimony, and tin, their KSP values are comparatively much greater, much smaller, 10 to the minus 30, minus 40, minus 50, like that. And group 4, zinc 2 plus, cobalt 2 plus, nickel 2 plus, manganese 2 plus, these have much greater KSP, 10 to the minus 11, 10 to the minus 12, So that if you want to prevent the precipitation of zinc sulfide, cobalt sulfide, manganese sulfide, nickel sulfide, this group 4 sulfide, you have to somehow reduce the sulfide ion concentration, which will be good enough for the precipitation of group 2 sulfides, but not good enough for the precipitation of group 4 sulfides. So that has been perhaps done. Let's see. The KSP of zinc sulfide is given so low. We are playing with values close to 0, as I was saying. And the zinc ion is 0.2 m. Now, the Ka1 and Ka2 of H2S we already know. So here, the zinc sulfide heterogeneous equilibrium is functioning with KSP, and the H2S homogeneous equilibrium is also operating in the presence of common ion, 0.5 m HCl. So first we have to find out, in presence of 0.5 m H plus ion, what will be the sulfide ion. First, let us see. So write the equation for Ka of H2S. The whole H2S, K1 and K2, both equations are added, HS minus is cancelled, so the K values are multiplied. So 10 to the minus 7 times 10 to the minus 14 becomes 10 to the minus 21. That is the K value for the net equation H2S giving 2H plus S2 minus, because we are not interested in the intermediate HS minus. So here, since we are using common ion effect, is 0.5 is predominantly higher value. So whatever little H plus ion coming from H2S dissociation is neglected. Should have been 0.5 plus X, but that X has been neglected. So since I'm writing down the equation, this is, homogeneous, all AC. So this will be 0.5 square, 0.5 plus X, supposing H2S, the number of moles coming out is X. So it will be 2X. So 0.5 plus 2X. And this one is X. I'm not writing X. I'm not writing 2X. I'm just saying that 2X has been neglected. Simply 0.5 square, because the coefficient is 2. And sulfide ion will find out in the presence of such a high value. Otherwise, it would have been simply this is X, this is 2X and square. This is 4X cube by 0.1. This is S2S, not like heterogeneous equilibrium. It will be omitted from the denominator, or taking it as 1. It's not. It's a homogeneous equilibrium and saturated solution of S2S. The S2S undissociated concentration is always 0.1 is given. So we found S2 minus in the presence of common ion effect is so low. But had it been no common ion effect, simply S2S, saturated S2S, we can find out is equal to, say, 4x cube by 0.1. So 4x cube is equal to 10 to the minus 22. X is equal to, supposing this is around 1 by 3. Ten to the power minus 7.3. See, it was so larger compared to what we are finding now. So the sulfide ion concentration has been greatly reduced because of a high dose of H plus ion from outside source, 0.5 m. Now let us see at this, what is the ionic product. Zinc ion concentration is fixed, 0.2. And now the sulfide ion that has to be there in presence of 0.5 m HCl is this. So the ionic product is coming this. But the KSP value is something greater. It is 1.2 times 10 to the power negative 22. So since IP is less than Ksp, precipitation will not occur. That means we have successfully prevented the precipitation. But if H plus ion is decreased from 0.5 to the extent that the sulfide ion concentration becomes 6 into 10 to the minus 22. So I have found out what is the saturation value. The saturated sulfide ion concentration is 6 times 10 to the negative 22. So if we reduce the concentration from 0.5 to some value, 0.4, we have to find out that. Then if this is maintained, then there is no precipitation. But below that H plus ion concentration, there will be precipitation of zinc sulfide. You understood what I said, Mr. Rudra?
Yes, sir.
So and we of course discuss about the theory of indicators. Indicator, there are 4 curves. This long horizontal portion, vertical portion, along the pre-equivalence and post-equivalence, that Johnny is sharply vertical with 1 or 2 drops of added. This is the volume of, supposing the titrant, say NaOH is used in a burette, and this is the pH. So start from the acid, only acid which has a low pH value. Suddenly at when the equivalence uh, time will come, then it will suddenly take a jump. So dpH by d volume of the liquid added will be 0. Influx, the influx point, that will give you 0 value. So which can be known by taking a indicator. Every indicator has a pH range. For example, litmus, so which is itself a weak acid, will be, at a lower pH value, the equilibrium lies towards the left and the HIN color is predominant. IN minus has a different color, HIN has different color. And I have told you that when HIN concentration by IN minus is equal to or more than 100, then the IN minus color will be totally masked by HIN. That happens at a lower pH. But at higher pH, the equilibrium shifts to the, in basic medium, so that OH minus eats away H plus ion, forming water, and the equilibrium shifts to the right. So ion minus concentration becomes greater. And if it is 10 times greater, that is, the ion minus is a very prominent, is a very, the intensity is much greater. Therefore, it needs 10 times more. But here for HIN, it needs 100 times more. Then you get the IN minus color is predominating, HIN is masked. So if you use, you can convert this to a Henderson type of equation, that this KIN or you can find out the pH is equal to pKIN plus log IN minus, which we call salt, by HIN. So making 10 by 1, this is a constant value. You get one extreme of the range, the higher one, and taking 1 by 100, you take the lower one. So for litmus, as you know, this pKIN is very coincidentally 7. And if we would put 10 by 1, so it will be how much? 8 when this is 10 by 1. And when it will be 1 by 100, it is 1 by 100, it will be -2. So the range is, pH range is 5 to 8. So this is the range for litmus, small range. Similarly, the phenolphthalein has a range in the basic region. Phenolphthalein is the only simple indicator. Its sister is there, thymolphthalein, but usually phenolphthalein is told to a +2 level. Has a color change range falling in the basic region. Methyl orange, methyl red, they have their range in the acidic region. That depends on the respective pKin values, which are fixed. And of course, taking 10 by 1, 1 by 100, you get a range. So that is before that, below 5, the indicator, litmus indicator will be perfectly red. Blue litmus turns red. And above it will be perfectly blue. And in between, the color is very, very mixed and it doesn't carry any diagnostic value. But if the equivalence point comes with a much greater range of vertical portion, then that short range for every indicator can be accommodated. Therefore, this is the titration curve for strong acid, strong base. I forgot to tell you. If you start with strong base, the curve will like this. If you start with strong base and add, acid as the titrant, and take base as analyte with a higher pH value and add acid, so that the pH will gradually decrease. It goes via a very long vertical portion, because the pre-equivalence point and post-equivalence points is quite wide. There is a drastic change of pH with only 1 drop or 2 drops of adding the titrant with the analyte. So all types of indicators, their ranges will be falling. If it is litmus, between this. If it is phenolphthalein, in this. It is methyl red, between this. So all indicators, all common indicators, can be used without any indicators can be used without any error. Otherwise, the color change will happen, but equivalence point has not reached, or the equivalence has already surpassed, but the color change not happened. This is wrong reading, wrong observation. So the other type of titration is this one. If you're coming from here, if you're coming, go there, this is 7, supposing. You are going via a very gradual rise, because throughout it is having a buffer solution, and in the basic region above 7, this is the vertical region from say 8 to 11, and that is taking weak acid and strong base titration. So you have to add volume of alkali base. Then only you can see the buffers living throughout the onset of equivalence, throughout. Because when you add little bit of this is used as an analyte, so the pH starts from a lower value, and you add NaOH as the titrant, and slowly you get NaCH3CONa. So there will be some unreacted acid, weak acid, and some formed salt, the conjugate base of the salt, conjugate base of the acid. So now it becomes a buffer solution. And as you continue to add more and more NaOH, a time will come, A pH will come, a volume of alkali will come when the acetate ion concentration or the salt concentration is equal to the unreacted acid concentration. So that log salt by acid, that log 1 becomes 0. So that pH will be equal to pK. So in between the starting point and the equivalence point, you will find at certain pH, you will find the two values you are adding. You know how much you are adding, what is the value. When the salt concentration becomes equal to this takes place when salt concentration is equal to the unreacted acid concentration. Then the log 1 will be 0. So that pH will be pK. And then, and the distinctly basic reason, because when all acid is consumed by exact equivalent quantity of sodium hydroxide, you get only salt. Such as salt due to hydrolysis, as many people call, but we say due to the basic dissociation of the anion, we get the solution is distinctly basic, and it falls in the 8 to 11 region, and therefore we choose phenolphthalein as indicator. You cannot take methyl orange, you cannot take litmus, because it will start showing change of color from lower pH value, but the equivalence point has not yet reached. It will indicate you, oh, stop. Once color change happens, that is called endpoint happens, you will stop the experiment. But equivalence has not happened. More NaOH is required to, still it is in the buffer state. So, if you want to come from this side, you will not enjoy buffer. Buffer will come after the equivalence point. It will come here. Buffer will come here. Suddenly you will get the drastic vertical portion, and then it will curve. You can do that, but if you enjoy before getting the equivalence point, you enjoy the different pH value at different salt to acid concentration, and slowly the salt is increasing, the pH is increasing, and finally near the equivalence point, it and at equivalence point it is no longer a buffer, it is a salt, pure salt. And during this point, still it is a buffer, but pH will be exceeding 7. But it is still a buffer. A trace quantity of unreacted acidic, unreacted weak acid is there, means it is a buffer. But it has exceeded 7. You can calculate. Similarly, for the third type of titration, you find that for that you have to come from, if you enjoy the basic buffer, then you start from this side, and the vertical portion will come at 6 to 3. So all throughout this buffer solution, and at when this is pH, not POH, or you can POH, if you take this as POH, then POH is equal to pKb plus log salt by acid. The salt is increasing. So POH is to increase, but pH is decreasing. So this is actually pH. But you have to find out POH will be increasing, but pH will be decreasing. Salt concentration is increasing. Supposing ammonia you have taken in the analyte and you are adding HCl from the burette. So the pH is decreasing, pH is decreasing, but actually if you calculate POH, salt is forming more and more, unreacted base is depleting, coming low and low. So pOH is increasing, so pH is decreasing. So at certain concentration where salt, ammonium ion and ammonia, they will be equal, that concentration you get is equal to pKb. So that pOH will be equal to pKb. pOH will be equal to pKb. So the corresponding, I am showing pH is equal to pKb. So pOH will be less than 7. 0.1 mole of, this is 20, this year, 2025. Oh, 25 is gone. 2025 JEE main. 1 liter of buffer solution was prepared by adding 0.1 mole of each of ammonia and ammonium chloride in deionized water, means pure water. The change of pH on addition of 0.05 mole of HCl to the above solution is dash times 10 to the minus 2, and the dash would be a nearest integer. So let us do it. Let us not be. Now pick up your pen and paper and your calculator. So ammonia means ammonium hydroxide. We write ammonium hydroxide. This is its dissociation. And there is a common ion effect, ammonium chloride is giving NH4 plus and Cl minus. Now the Henderson equation is this, POH. It is a basic buffer, so it will be POH. Yes or no? pH. What?
Sir, pOH.
pOH is equal to pKb plus log salt by base on react. I mean base. So since it was, let us find out before adding HCl. It is pKb 4.745. It is asking the change. 4.745 plus log 0.1 by 0.1. So it is log 1 0. It is simply 4.745. But if you add H plus ion, which will eat away forming water, this will go. So equilibrium will be driven to the right. Salt concentration will increase and this concentration will decrease. The same amount, 0.05, will be added to 0.1 and subtracted in the denominator. So the new pOH after adding HCl is 4.745 plus log 0.1 plus 0.05 by 0.1 minus 0.05. So it is 4.745 plus log 0.15 divided by 0.05. So it is log 3. Yes or no?
Yes, sir. Yes, sir.
So plus the value given, let me show you the exact value it is giving. Log 3 is equal to 0.477, which we already also know. कितना हुआ? So the difference is this. So delta pH, pOH will be same as delta pOH. The difference in pH scale and pOH scale will be same. So it was 4.745 and this is 4.745 plus 0.477. So it is asking the change in pH is this. So the change is 0.477, and it had to express it in the form of 10 to the minus 2. So it should be how much? 47.7.
47.7.
So that it will be 0.47. And the nearest integer is 48. Yes or no? So the correct
Yes, sir.
answer is 48. So see how easy is the, you can just have a look whether you have done correctly. 48. Yes, it is 48. Okay.
Yes, sir.
Now I feel like solving a problem again from below. We'll going up and down. Let's take say 36 for example. Let us solve a problem on solubility product, heterogeneous equilibrium. The two salts A2X and MX have the same value of solubility product. That is 4 times 10 to the minus 12. The ratio of their molar solubilities S by S is dash. Round up to the nearest integer. It's very simple. Yes or no?
Yes, sir.
This will be 4xq is equal to etiki. You find out what is x. This is x square is equal to etiki and find out y. Y square is equal to etiki, find out y. So take the ratio x by y and round up to the nearest whole number. Yes or no?
Yes, sir. Yes, sir.
Now let us do a problem 38, which is based on the common ion effect in heterogeneous equilibrium. The solubility product of lead iodide is 8 times 10 to the power negative 9. The solubility of lead iodide in 0.1 molar solution of lead nitrate, the example I was giving, is x times 10 to the minus 6. The value of x is this. Do it and tell me. This is heterogeneous equilibrium. And there is a common ion effect lead nitrate. And this is the common ion. So let X is the solubility after. So it is, let's say, Y is the solubility because X, it is to be expressed as X times 10 to the minus 6. So Y plus lead ion coming from the lead nitrate is 0.1. It is 1, 1. So Y plus 0.1 is the lead concentration because that is the common ion, and 2Y is the iodide ion concentration. That is the uncommon ion. Solubility is known from the uncommon ion, 2Y, because we have taken solubility as Y. If you take I minus concentration as something P, then solubility would have been P by 2. But here we have taken solubility as Y, so I minus concentration is 2Y. And it is Y plus 0.1. So if you write down the KSP expression, it will be Y plus 0.1 into 2Y square. But here tactfully you have to neglect Y. So this is given 8 into 10 to the minus 9 is equal to 0.1 into 4Y square into 0.1. So it will be 2 here, and this is 1 by 10. So this will be 20 into 10 to the minus 9 is equal to Y square. So this will be 2 into 10 to the minus 10, sorry, minus 8. So y is equal to root 2 into 10 to the minus 4. I think root 2 value is given.
Yes, sir.
Root 2 value is 1.41, simply 1.41. So 1.41 into 10 to the minus 4. This is y. So we have to express as, I don't know, there is a chemistry guys there wanting to see that the IIT aspirants are not bad at this mathematics calculation. So in the form of 10 to the minus 2. So if you put it in the form of 10 to the minus 2, then it will be 1.41 into 10 to the power minus 2.
Sir, sir, ତଳେ ଥିଲା question ଟା sir. Sir, -6. Sir, या ପରଟା.
Oh, wait, I thought. Oh, 10 to the minus 6. Oh, sorry. So you have to put it in the form of 10 to the minus 6. So what to do?
Sir, multiply by 100.
10 to the 4, 10 to the 2, right?
Yes, sir.
Into 1.41. This will become 10 to the minus 4. So ultimately, if you make it, it will be 141. So it is 141 is the nearest integer. Yes or no?
Yes, sir.
Is there any doubt? Is there any possibility of error?
No, sir.
ये किया जाए, लॉक किया जाए,
Yes, sir.
कंप्यूटर में ऐसा लॉक किया जाए. Oh yeah, correct. So you find, let us solve a problem whether precipitation will happen or not. There are so many mix up ହେଇଯାଇଛି, then conductivity ତା ଭିତରେ ପୁରେଇଛି. K of acetic acid is this, Kb of ammonium hydroxide is this. These are identical, so pH of ammonium acetate will be exactly 7. Yes or no?
Yes, sir.
Half into pK W plus pK minus pKb, so they are identical, so that will cancel out, so it will be 7. Again, this is acidic buffer. The volume of benzoic acid solution in 300 milliliter of the buffer solution is -L. Indirectly, it is talking of mixing. That means that now see this question. It appears to us as a weird question unless we think that it is a mixing problem. The pH of aqueous solution of 1m benzoic acid and 1m solution which is 1m benzoic acid and 1m sodium benzoate is 4.5. The volume of benzoic acid solution in 300 milliliter of the buffer solution is -ml. The total volume is 300 ml. So out of which, supposing 200 ml is of benzoic acid and the remaining 100 is of sodium benzoate. So that it is asking to find out. This question, some questions are really not logical. The question setter has lost some of it, the logic. Think something else and asking something else. So I think we will neglect this question because it lacks a clarity. We will not discuss this question. However, you can try, this is an easy one, you can just guess and see. The pH of an aqueous solution containing 1 benzoic acid. That means, if pH is 1, if the pK value is 4.2 and well, the pH is 4.5, obviously the salt and the acid concentrations are not same. So 1m, that means you have to presume that before adding it was 1m. But after adding, because the two volumes are not same, out of 300, 200, 100, supposing 250, 50. So they have changed. The final concentration has changed. So therefore, you cannot say 1m, its value is nothing. So supposing we will solve this problem, understanding what the question setter is thinking. Supposing x ml of 1m benzoic acid. Remember that this is not is a wrong thing. It's added. X milliliter of 1m benzoic acid is added with 300 minus x milliliter of 1m sodium benzoate. So you have to find out that x. So the number of moles will be, millimoles will be x. So pH will be equal to 4.2 plus log, because it is a ratio, so moles by moles will also do, x divided by, this is 300 minus x into 1. So this is given to be 4.5. You got it?
Yes, sir.
So you have to solve this. This is log x by 300 minus x is equal to 0.3. So which is equal to log 2. Yes or no?
Yes,
Arre,
sir.
0.3 is it
Yes,
not
sir.
log
Yes, sir.
2?
Yes, sir. Yes, sir.
So this log, so say the x by 300 minus x is equal to 2. That means x is equal to 600 minus 2x. So 3x is equal to, so I was just predicting x is coming to be 200. So x you have taken benzoic acid solution. So it is coming 200 ml. The volume of benzoic acid is 200. Got it?
Sir.
So, well, you can think it is an indirect question for the students to think that if it is the buffer is 1m benzoic acid, 1m benzoate, then the pK value would have been same as the pH value would have been same as pK, but it is different. So it is a mixing problem. Got it?
Yes, sir.
So let us see. I think we have rightly diagnosed the trick. I mean the trap that the question setter wanted to put. So this is, simply you have to look for the, sorry, you have to look for the stoichiometry. See, 3 gram of acetic acid, 41, added to 250 ml of 0.1 MSCl, and a solution made to 500. This is dilution problem. To 20 ml of this solution, half ml of 5M NaOH is added. So there will be definitely some excess. So pH of the solution is now 3 by 60. Acetic acid is 60. So we have taken 1 by 20 mole of acetic acid into 50 ml water. 250 milliliter solution. And whatever was to the earlier volume 250, it was now made to 500. So now the volume is 500. Forget about 250. So 3 gram is present in that is 3 by 60 moles now is present in 500 ml, and 0.1 into 500, that is 50 millimoles is present here. 1 by 20 means into 1000, that is 50. Fine. So again it is 1 by 3 minus log 3. So ultimately you get 4.75 minus 0.477, and just do it for me. You understood what I said?
Sir, ଏଠି ଉପରେ 0.5 Sir, plus 0.477
प्लस केमती एटे सॉल्ट होची 0.5 आउ अनरिएक्टेड एसिड इज 1.5. So
Yes, sir.
0.5
Salt
by
upon
1.5. Huh?
Oh, sorry, sir.
So 1 by 3 हेले minus log 3 हे गला. So 4.75 minus 0.477. जोटा हबो ने, because we are doing in math in orally, हमें ताकू टिके पेन एंड पेपर रे करिले. Because a volumetric analysis, we are quite proficient, very familiar with. We are supposed to be, therefore, I am saying. Now see, 3 by 60, 1 by 20 into 1000, 50 millimoles in 500 ml ଅଛି. Ultimately stock solution टा 500 ହେଲା. এটা তো মাস ଦେଇଛି মানে millimoles ବାହାରି ଗଲା. এটা acetic acid. And 250 into 0.1, that is 25. अरे तो 25 थिला. हाँ, now 25 millimole अच्छी किंतु 500, हाँ 25 millimole. Sorry, 25 millimole है गला अच्छी माने ताकू 500 बर्तन 500 मिलीलीटर अच्छी हैला.
Yes,
बुझिलो.
sir.
So 25
Yes, sir.
millimole अच्छी, and थेटा को तार वॉल्यूम बर्तन है गला 500 रे, made up to 500. से थ्रू 20 ml आसला. 20 ml रे the 500 by 20 केते 25 times less. So 50 by 25, 2 millimole of acetic acid ता देहरे थिबो, and 25 by 25, 1 millimole थिबो HCl. ताकू आमे ऐड कले केते ना half into 5, 2.5 millimole ऐड कले NaOH ऐड कले से आगो खाइबा आकू. So 2.5 minus 1 HCl चली गले रहिला 1.5. तापर 1.5 अरे हाँ रु भूल है लॉग प्लस हबो रु 1.5 खाइला एसिटिक एसिड. So 1.5 millimole salt है and excess उल्टा ही दिला मोर नहीं. So 2 minus 1.5, 0.5 millimole रहिला unreacted acetic acid. बुझलो?
Yes, sir.
So now pH is equal to 4.75 plus log salt is now 1.5. You are correct. And unreacted acid is 0.5. It is log 3. 4.75 plus 0.4771. So କେତେ ହେଲା? ଦେଇଛି ନା ସେଇଆ? 4.771.
Sir, 5.2271.
5.22.
2271.
So এইটা ହେଲା ସେ ପଚାରିଛି କ'ଣ? The pH. Definitely nearest ଇଏ କୁ କରିବ. Nearest କ'ଣ ଆସିବ?
5.
5 ଆସିବ. So ଦେଖିବା ଲକ୍ କିଆ ଯାଏ.
Yes, sir.
ସିଏ ପଚାରିଛି ଆନ୍ସର to the nearest 10th place of decimal to 100th place of decimal. ନା ବିଶେଷ ପଚାରିନି କିଛି. ତାହେଲେ 5.22. ଠିକ ଅଛି.
Yes, sir. Yes.
5.24 କୋଉଠୁ ଆସିଲା? କାହିଁକି ତାର 24 କାହିଁକି ଦେଲା? ଏକ୍ଜାକ୍ଟଲି ଭ୍ୟାଲ୍ୟୁ ତ ଦେଇଛି. ତାହେଲେ what made it to predict 5.22 ତ ଆନ୍ସର ଆସିଛି. ସେ ଏଥିରେ କିଛି ଦେଇନି. କିନ୍ତୁ ନଦବ କେମିତି? ଏଇ ଟାଇପର ତ କ୍ୱେଶ୍ଚିନରେ ଡେସିମାଲ. ହଁ ଡେସିମାଲ ଅଛି. ଆରେ ଅଛି 5 ଏ ଡେସିମାଲ ଅଛି 0.22. ଏରେ ନିୟରେଷ୍ଟ ହୋଲ୍ ନମ୍ବର କହିନି, ଏକ୍ଜାକ୍ଟ ପଚାରିଛି 5.22 ହେଲା.
Yes, sir.
ଏକ୍ଜାକ୍ଟ ଇଣ୍ଟିଜର ନିୟରେଷ୍ଟ ଇଣ୍ଟିଜର ସେ ପଚାରିନି, ସେ ଭ୍ୟାଲ୍ୟୁ ପଚାରିଛି. 5.22 ହେଲା. ଠିକ ଅଛି. So I think by now you are getting a feel.
Yes, sir.
And see, these are previous year's questions. Now, I would like to take this type of question so that your knowledge about the solubility product from analytical chemistry has to be used. Sulfides as well as this chlorides and other things will come. ଏଠି ଗୋଟେ ଭୁଲ ଅଛି, ମୁଁ ଦେଖି ସାରିଥିଲି 1/5 ହେବା କଥା. No, see, mercurous chloride is in group 1. It is sparingly soluble. Barium sulfate is in group 5, sparingly soluble. All sulfates are soluble. ଏଥିରେ barium chromium ନାହିଁ. strontium barium lead ଅଛି, chromium ନାହିଁ. ଏଟା soluble ପୁରା. all chlorides are soluble, ସେଥିରେ chromium ନାହିଁ. ସେ ପଚାରିଛି ଅବଶ୍ୟ ସେଇଟା ପଚାରିନି, solubility ପଚାରିନି, sorry. ସେ expression for solubility and the correlation between solubility and KSP. এইটা ଭାଙ୍ଗିବ କ'ଣ? Ag2 2 plus ये गोटे आयन, गोटी आयन plus 2Cl minus. এটা 4x3 मेथड रे. 4x3 मेथड माने 1/3 ରହିବ. by 4 to the power 1/3 ରହିବ. କୋଉଥିରେ ଅଛି? ପ୍ରଥମଟା ରେସ୍ପେକ୍ଟିଭ ଦେଇଛି ମାନେ ଏଇଥିରେ ଅଛି, ଆଉ କୋଉଥିରେ 1/3 ଅଛି? ଏଇଥିରେ ଅଛି, b ରେ ନାଇଁ ଏଟା ଦ୍ୱିତୀୟରେ ଅଛି. ପ୍ରଥମରେ କୋଉଟା ଅଛି? ଏଇ ଚତୁର୍ଥରେ ଅଛି. will competition ହବ କାହା ଭିତରେ? ନା A ଆଉ D ଭିତରେ. ପ୍ରଥମରେ 4x3 ମେଥଡଟା ଅଛି, ଆଉ ପ୍ରଥମରେ କୋଉଠି 1/3 ନାହିଁ. C ରେ ମଧ୍ୟ 1/3 ନାହିଁ, D ରେ ଅଛି. ନାଉ ଆମେ ଦେଖିଦେବା ଏଇଟା ବେରିୟମ ସଲଫେଟ ହେଉଛି ଟୁ ଦି ପାୱାର ହାଫ୍. ଲାଷ୍ଟ କୁ ଟୁ ଦି ପାୱାର ହାଫ୍ କୋଉଟା ଅଛି? ଖାଲି ଟୁ ଦି ପାୱାର ହାଫ୍. ସରି,
First.
ନା ଏଟା ଥାର୍ଡଟା. ଫୋର୍ଥଟା ହେଉଛି 27. 20/27 into to the power 4 କୋଉଠି ଅଛି? ଲାଷ୍ଟଟା.
Sir, faster ଅଛି.
ଏଇଠୁ ଜଣା ପଡିଗଲା ଏଇଟା ହିଁ ହବ. ଦ୍ୱିତୀୟଟା এটা actually হবা কথা কেতে জানিছ টু দি এটা ভুল আছে এটা টু দি 1/5 হবে নয়
Yes, sir.
3 3 9 3 27 2 দুনে 4 27 চৌ 108 ঠিক ଅଛି কিন্তু পাওয়ারটা হবো টু দি পাওয়ার 5 নয়
Yes, sir.
বাকি এইটা হাফ আছে ঠিক আছে এটা ব্যারিয়াম সালফেটের হাফ আছে এইটা খালি মিসিং কোটি 1/5 নাই তো ভুল করছি কোশ্চেন গট ইট
Yes, sir.
এইটা ବି ସେମିତି ଗୋଟେ 3x ର ହୋଲ୍ କ୍ୟୁ 4y ସରି 4x ର ହୋଲ୍ 4 କରିକି ବାହାର କରିବ ଆଉ ରିଲେସନସିପ୍ ଭେରି ଇଜି ବୁଝିପାରୁଛ
Yes, sir.
ସୋ ଏଇଟା କମନ୍ ଆୟନ୍ ଇଫେକ୍ଟ ପକେଇଛି ସେ ଇନଡାଇରେକ୍ଟଲି ଏଠି ଦେଇ ଦେଇଛି S2S ର ଫାର୍ଷ୍ଟ ଡିସୋସିଏସନ କନଷ୍ଟାଣ୍ଟ 10 to the minus 7 ସେକେଣ୍ଡ ଆମେ 10 to the minus 14 ନଉ ସେ କିନ୍ତୁ ଦେଇଛି 1.2 10 to the minus 13 ଡଜଣ୍ଟ ମ୍ୟାଟର ଯାହା ଦେଇଛି ଆମେ ୟୁଜ୍ କରିବା ଏ ଇନଡାଇରେକ୍ଟଲି କହୁଛି ସେ ସେଇ ଜିନିଷ S2S ର ଡିସୋସିଏସନ ଏତିକି ଆଉ HS ମାଇନସ୍ ର ଡିସୋସିଏସନ ହେଉଛି ଏତିକି ତା ମାନେ K2 ତ ସେଇଥିରୁ ତମେ ବାହାର କରିବ ହ୍ୱାଟ ଇଜ ଦ ସଲଫାଇଡ୍ ଆୟନ୍ କନସେନ୍ଟ୍ରେସନ କମନ୍ ଆୟନ୍ ଇଫେକ୍ଟ ହେଇଗଲା ନା तो पूरा मूलरू देवाक पड़िबो कारण H प्लस आयन कंसंट्रेशन टा 0.2 नवाक पड़िबो एंड एठी जो आसी 2x टाको काटी देवाक पड़िबो नेग्लेक्ट कर देवाक पड़िबो गॉट इट दीटा को
Yes,
के
sir.
गुणिबो एठी तीटा को के गुणिलो एठी गुणिले फाइनल के बाहरला 2h प्लस जगह 2x आसला प्लस कॉमन आयन आडू 0.2 सो 2x प्लस 0.2 रो स्क्वायर प्लस सॉरी इनटू सल्फाइड आयन कंसंट्रेशन is equal to say जो गुणफलटा k1 k2 रो गुणफलटा and then neglecting 2x in the parenthesis के square रहला 0.1 रो square into sulfide ion is equal to एतिकी हेले sulfide ion concentration केते हबो बुझिला
Yes, sir.
pH of 10 to the minus 8 m HCl ହେଲା ମାନେ definitely less than 7 हबो कि नहीं
Yes, sir.
between 6 and 7 कारण हमें जो अच्छी से केस रे 10 to the minus 7 कि बता तळु को आसले we have to take the dissociation of water into account नुए
Yes, sir.
एंड क्रूडली हमें 10 to the minus 8 सॉरी 10 to the minus 7 को ऐड कर दो किंतु एक्चुअली यू हैव टू डू इट इन ए एलिगेंट वे बाय टेकिंग डिसोसिएशन कांस्टेंट ऑफ वाटर आई मीन यस डिसोसिएशन कांस्टेंट ऑफ वाटर को नहीं करियो अरे के आयनिक प्रोडक्ट को नॉट डिसोसिएशन कांस्टेंट आयनिक प्रोडक्ट को नहीं करियो रिफाइंड आंसर मिलेगा आर यू एबल टू फॉलो मी
Yes, sir.
Let us solve this problem. I have marked it. A certain weak acid HA has dissociation constant 1.8 times 10 to the power negative 4. The equilibrium constant for its reaction with a strong base is. Just do it and tell me. आउँ देखो এটা এতে করা আছে এইটা তো আমি করলে বর্তমান মুহে মুহে করদেলে এটা 5.22 जो बाहर दिला yes hello and welcome those who are watching live it is already 1 hour 32 minutes gone and we have come to the end of our class. I think we will conclude today's class. By now, I'm sure you must have, those who are following these two videos very closely, must have got a feeling that ionic equilibrium is not at all difficult. But the one thing which I could not find questions from last year's is conjugate acid base, giving the order and selecting which is strongest. As I have told you yesterday, that conjugates, they have their K values equal to pK value. Pk plus pKb of conjugates is 14, just like pH plus pOH of any solution is 14. pKa plus pKb of its conjugate will be equal to also 14. Or Kb is equal to K 10 to the power minus 14, or Ka into Kb is equal to 10 to the power minus 14. This has been was discussed through taking the concept of hydrolysis of salt, acid dissociation and basic dissociation of the conjugates. With conjugate is neutral, we call it acid dissociation. But its conjugate base is an ion, we say salt hydrolysis. But let's say it is basic dissociation of the anion. So you find that they cancel out and they form Kw. So the product of Ka and Kb of conjugates is equal to Kw. And using that you can solve many things. So it halaki ho gaya kya?
सर मोर 1.8 into 10 to the power 9 आसुची.
Fantastic. Fantastic. Let us import this. Guys who are watching this, can anyone write? Now, for any acid-base reaction, acid-base reaction, definitely the conjugates will be found on the right side. इसका conjugate ये है, इसका conjugate ये है.
सर
लेकिन हाँ,
सर मोर सर आसुची 1.8 into 10 to the power 10.
okay.
माने
Let's see.
सर माने ऑप्शन मैच करनी.
एटा ऑप्शन मैच करूनी ना?
नहीं सर.
Okay. So the fundamental principle जानिବାକୁ पड़िबो in acid base reaction. The fundamental concept is a strong acid will displace a weak acid from in a acid base reaction, or a stronger base will displace a weak. This BHA is a stronger base than DH plus. This and B as acid strength, and B is stronger than BH plus. B is stronger than HA1. B is the base here, and B is stronger than A minus. This is for spontaneous process. When I say spontaneous, I mean right favored. Or the reaction will happen, otherwise it will not happen. ସେଥିପାଇଁ ଏଇଭଳି reaction ରୁ K equilibrium, which is equal to K କିମ୍ବା KB, ଯାହା ତମେ କର, K KB ନୁହଁ, acid base reaction equilibrium constant, I'm sorry, equal to Ka of LHS by Ka of RHS, or Kb of LHS by Kb. এটা ଗୋଟେ ইম্পর্টেন্ট জিনিস মনে রাখ, ইকুইলিব্রিয়াম কনস্ট্যান্ট এটা যদি 1 ରୁ ଅଧିକା ବାହାରିଲା 10 to the power positive something, then it is highly probable it will happen. 10 to the minus something ବାହାରିଲା, less than 1 ବାହାରିଲା, it is highly improbable it will not happen. So ଏପଟେ ଏସିଡ ହେଉଛି HA, ଏପଟେ ଏସିଡ ହେଉଛି BH ପ୍ଲସ୍, ଏପଟେ ଯାହା କଲେ ବି ଆନ୍ସର ଏକା ଆସିବ. ସୋ ଦେଖ ଏଇଠି ମୁଁ କରୁଛି H ର, so K equilibrium constant will be H ର ହେଉଛି 1.8 into 10 to the minus 4 divided by, किंतु एठी रिएक्शन टाको लिखिनी परा, HA plus base होची OH minus, I am sorry, A will be equal to water plus A minus. So here HA is acid, here acid is A2, base is B1, This is B2. A1, B2, they are conjugates. B1, A2 are conjugates. But we are looking to A1, A2, B1, B2 to find equilibrium constant. So HA is given, but you have to find out the acid dissociation constant for water. Kete? Kalika video. Huh?
KW 10 to the minus 14.
Are you kidding me? Dissociation constant, not ionic product. I told you that water gives you H plus OH minus. So KD, dissociation constant, is equal to KW, etar gunaphala, by 55.55. So 10 into 10 to the minus 15, 10 into 10 to the minus 15 by 55 point, or 100 into the minus 16 into 55.55. এটা কেতে ହେଲା? 100 रे 55.55
Sir, 1.8.
8
Yes, sir.
into 10 to the minus 16. এইটা ହେଲା KD. So ସେଇଟା use କରିବାକୁ ପଡ଼ିବ. So Ka of water as acid equal to Kb of water as a base. This is amphoteric, is same. And pKa of water is same as pKb of water, that is equal to 15.74. এটা কলে কেতে আসছে? সেদিকে আসিব 15.74 ହେଲା।
Yes, sir.
ତେଣୁକରି pKa of hydronium ion, which is equal to pKa of hydronium ion, are a conjugate. Water as a base, they are conjugate acid. Yeah, as a acid or conjugate base, pKb of hydroxide ion is equal to minus 1.74. I'm sorry, minus 1.74. They are strong bases, strong acids. Hydronium ion is a strong base. I told you. Sorry, strong acid. All strong acids, they level up at moderate concentration as H3O plus. K values are not 10 to the minus 7, or sorry, 10 to, sorry, plus 7 into plus 10. It will be 10 to the power, 1.74. Got it?
Yes, sir.
আমার দরকার ওয়াটার as pKa. pKa of water is 15.74. हो कि नहीं? pK नो, Ka দরকার. K. pK হলে add হবো. pK হলে sorry, when you are dividing, then pK value গুড়া কোন হবো? Subtract হবো না add হবো? Minus
Sir, minus subtract
Ka
was.
by Ka dash. K LHS, এটা RHS. মাইনাস লগ নেই গলে কোন হব?
Sir, minus of.
মাইনাস লগ কে মাইনাস মাইনাস প্লস হয়ে গেল কি নেই? পুଣି যদি মাইনাস লব মাইনাস লগ কে ড্যাশ। সো এটা পিকে মাইনাস পিকে বি এ পিকে এ ড্যাশ। সো লেফট মাইনাস রাইট যদি পিকে ଦେଇଥିବ তাহলে ফেডি দেব। দ্যাট উইল বি দি পিকে অফ দি পি অফ দি ইকুইলিব্রিয়ম কনস্টান্ট। সো ଆମେ ତ কে ভ্যালু ବାହାର କରିବା। সো ইকুইলিব্রিয়ম কনস্টান্ট ইজ ଦେଇଛି କେତେ? लेफ्ट हैंड साइड रो इक्विलिब्रियम कांस्टेंट देइछि केते ना 1.8 * 10 to the minus 4 and right hand side water as an acid equilibrium constant is 1.8 * 10 to the minus 16 তাহলে কেতে হলা ও বাবু?
10 to the 12.
So it is highly probable. So any acid sangare OH minus and dela mane weak ho strong ho, it is highly probable. এটা যদি মাইনাস আসথান্তা, such acid base reaction is improbable. ଏକାଂଶରେ ଆସିବ ଯଦି ତମେ ଇଏ କରିବ, OH minus is এটা 10 to the minus 14 ରେ ଡିଭାଇଡ୍ କଲେ ବାହାରିବ OH minus ର, ଏବଂ ଏଠି ଅଛି OH minus ର Kb ଏବଂ ୟାର Kb হচ্ছে 10 to the minus 14 একা কথা নুহ 10 to the minus 14 ডিভাইড করলে যে 1.8 10 to the minus 5 সেটা বাড়িব সো kb by kb মধ্য will give the same result, that is 10 to the 12, yes or no?
Yes, sir.
সো এটা ଗୋଟେ কমপ্লিটলি নূয়া তথ্য জানলো কি নাই গাইস?
Yes.
So any acid base reaction is right favored or left favored, will happen or not, or equilibrium constant, say pacharchi or equilibrium constant is equal to left acid, right acid. They are not conjugates. Conjugate হচ্ছে বেস কিন্তু অ্যাসিড নেବାକୁ ପଡ଼ିବ ଆରଟାର conjugate ତାର ରେସିଓ ନେଇଗଲେ ହବ କିମ୍ବା pKa left minus pKb right, that will be the P equilibrium constant. Got it?
Yes, sir.
ସେ ଗୋଟେ କୋଉଠି ଦେଇଥିଲା ଯେ ବଫର ସଲ୍ୟୁସନ ରେ ଅଙ୍କ କରାହେଇଛି, ଏଇଟା ତ ମିକ୍ସିଂ ପ୍ରୋବ୍ଲେମ କିଛି ନୁହଁ। and you know in mixing problem ଯଦି titration মানে mixing কରୁ কରୁ if you get something, some strong partner is remaining in excess, then the salt has no role to play. You ignore salt, find out the excess OH minus or H plus and find pH, right?
Yes, sir.
Yes, excess weak acid or weak base remains, then salt has to be considered and Boffer solution equation has to be used. If there's exact equivalence, then salt hydrolysis, you get same millimoles of salt, but you have to add the volume, divide by volume because we need the molar concentration. But in Henderson equation, you need not take the molar concentration, the volume term cancels, it's the ratio. Mole by mole, millimole by millimole will do. And even if there is a salt and a strong acid, I told you that sometimes you are given a salt like sodium acetate, say 200 ml of 0.1 m sodium acetate is mixed with say 50 ml of 0.1 m HCl, then find the pH. Of course it will be giving you pKa of acetic acid is fixed 4.74. So how you judge what will happen? Salt is given, is mixed with acid, strong acid. Yes, tell me how you proceed. Here, the acetate ion will immediately grab H plus ion to form undissociated acetic acid. Because if the dissociation constant is 10 to the minus 5, the formation constant is 10 to the plus 5. So it is highly right favored and spontaneous. So all acetate ion will vanish. I have given H plus as the limiting, sorry, all H plus ion will vanish from strong acid because this is 5 millimole, this is 20 millimole. So this is excess, this is, so 5 millimole will eat away 5 millimole and this will be 0 and this will be 20, is 15 millimole will be unreacted salt and the form will be 5 millimole of acid, the other way around. And there salt was being formed and excess acid was remaining to form a buffer. Here acid is formed and excess salt is remaining, so that you put pH is equal to 4.74 plus log salt remaining is 15 by acetic acid form is 3 log 3. So you understood?
Yes, sir.
So I think we close to the session. Um, Then the ball is in your court. Solve as many problems as you like, and MCQs, multiple, more than one correct answer, statement type, and assessment and assortment type, reasoning type. Do everything and ask your doubts. Okay, guys.
Yes.
If you have enjoyed the class, then don't hesitate to hit the like button and subscribe to my channel if yet not. Bye bye. Next.
Pronouns?
Hey, ଶୁଣ
Yes, sir.
ନେକ୍ସଟ ନେକ୍ସଟ କଣ କରିବ ଆଉ କଣ ଥିଲା କି?